Classifying systems of linear equations from a graph. So our first one, if they give us y equals 1/3 x and x plus 3y equals 0. Okay, so they will give you a graph. So the graph looks something like this. That's a negative here. Okay, so your graph's going to look something like this, let's say, not drawn to scale. What happens is there's supposed to be two graphs here. Two lines here. But if you solve this for y, which you don't have to do, it gives you the same line. So I kind of say for my notes here that they're the same line. And there's two categories it goes into. This system is consistent dependent. So that's the first thing we can call this system. And the key is when you're looking at two lines, the answer to a system is where they intersect. Well, because the two lines are on top of each other, all these points are all intersection points. So when you have two lines that are the same, we say there are infinitely many solutions. Okay, so two lines, it's the same line, they're consistent independent, and all the points are touching, there's infinitely many solutions. Number two, our most traditional scenario. We have y equals negative x plus 5 and y equals 2x minus 1. So I'll try to save a little paper here. Okay, negative x plus 5 looks something like this, not drawn to scale. And 2x minus 1 looks something like this. And I'll tell you where this will intersect is 2, 3. Okay, a scenario like this is the most typical scenario. The two lines cross at one point, this is your solution. So I'll get to that in a second. So this is called, so something with an answer is called consistent. But this one's consistent independent. And it has a unique solution to 3, the intersection point right here. So there's our unique solution. So two lines that only touch once, they have one answer. Two lines that are on top of each other, infinite number of solutions. And the last one. Excuse my drawing here. It's probably not going to look perfect. Okay. So our third scenario. What happens if we have 1/3 x minus 3 and y equals 1/3 x plus 3? Well, what this graph would look like is something like this. So say it's something like that, and maybe something like that. And my drawing is a little bit off, no surprise. These two lines are parallel. That means they'll never touch. So in this case, this is called an inconsistent system. And if these never touch, how many answers do we have? Well, this one is there's a no solution. So if they're parallel, the system is considered inconsistent, and there is no solution. There's no answer. Over here, just to go over it again, the same line is consistent dependent. One answer is consistent independent system. This is a consistent dependent system. This one has infinitely many solutions. This has one solution, a unique solution at the point 2, 3. And that concludes this section.